Hi everyone, today I'm going to give a short introduction to our paper, which is about a new set-based HTN plan verification method. The goals of this paper include developing a new set-based HTN plan verification method by using so-called path decomposition trees and solution order graphs, which are two data structures used in the state-of-the-art set-based HTN planner, and re-implementing the existing set-based HTN plan verification method in C++. Well, in this talk, we will not discuss this re-implementation because it is just a simple translation from the original Java code to C++ code. Well, as a start point, I want to quickly introduce HTN planning and some important concepts. Generally speaking, HTN planning is about using methods to decompose so-called component tasks until a primitive plan is obtained. In particular, such a decomposition process is captured by a decomposition tree. So, for instance here, the trees colored with green and pink respectively represent a decomposition tree. Further, a path decomposition tree is a data structure which stores all possible decomposition trees with respect to an HTN planning problem. A solution order graph is essentially the leaves of a path decomposition tree constructed in an order-consistent manner. Well, the best thing about our new set-based method is that we only need to construct set clauses to encode that there is a subset of the vertices of a solution order graph which has a bijective mapping to a plan that is to be verified. So for this purpose, we need to encode 4 constraints. The first one is that if a node is mapped to an action, then this node must be labeled with the same action name. The second one is that a node is activated if and only if it is mapped to some action. The third one is that every node can be mapped to at most one action. And the last constraint is that every action has one node that is mapped to it. Well, in our empirical evaluation, we compared our new set-based method with the re-implemented one on the benchmark set from the IPC 2020 on HTN planning. Well, as we can see here, our new set-based method significantly outperforms the re-implemented one. In our future work, we want to add some missing functions and make some optimizations. For instance, we want to add support to method preconditions. We want to calculate a tight bond for the maximal depth of a decomposition tree, and we want to remove non-necessary methods and tasks. So in conclusion, in this paper, we develop a new set-based HTN plan verification method based on path decomposition trees and solution order graphs, and we re-implement the existing set-based method. Well, Our empirical evaluation shows that the new set-based one is significantly better than the re-implemented one. This is the end of my talk. Thank you so much.